A Kafka Streams app crashed every 2 hours with out-of-memory error, even after doubling heap to 8 GB. The root cause? The RocksDB state store was set to heap mode, storing all 24-hour windowed aggregates in memory, growing unbounded. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover stream processing. Stream processing is like a conveyor belt. You inspect and act on each item as it passes by, without ever stopping the belt. You get results instantly, but you need to handle out-of-order events and bursts. Batch processing is simple: collect data for an hour, then run a job. But the latency is the window size. Stream processing keeps a persistent pipeline, processing each record as it arrives. The trade-off: you must manage state, ordering, and failures continuously. Here's a batch loop that polls every 10 minutes. It has 10-minute latency and potential duplicates if the process crashes after processing, but before updating. The stream approach filters events as they arrive, with millisecond latency and exactly once with proper config. You have 3 main options. Kafka Streams is lightweight, runs in your app process, and is perfect for simple transformations and joins. Flink is a heavy-duty cluster framework with advanced windowing. Spark Streaming is micro-batch, not true streaming, but good if you're already in the Spark ecosystem. Kafka Streams is embeddable and simple. Flink gives you event-time windows. Spark Streaming uses micro-batches with 1/5-second latency. Start with Kafka Streams, graduate to Flink only when you hit its limits. State is where stream processing gets hard. Every join, aggregation, or window stores state. That state lives in memory or on disk, and it must survive failures. Kafka Streams uses RocksDB backed by Kafka changelog topics. Flink uses checkpoints. Always configure a custom RocksDB config setter to cap memory. Default RocksDB config can grow unbounded and cause OOM. Set write buffer size and block cache size explicitly. Exactly once means each record is processed exactly one time, even if the producer retries or the consumer crashes. Kafka Streams achieves it via idempotent producers and transactional writes, but it adds latency and reduces throughput. Enable exactly once with processing guarantee CONFIG set to exactly once v2. Also set idempotence and ax equals all. For Flink, set write semantic to exactly once and enable checkpointing. Backpressure is when your producer sends data faster than your consumer can process. Without handling it, you'll OOM, drop messages, or crash. Kafka handles backpressure naturally. Consumers pull at their own pace, but lag grows. Limit batch size with max poll record CONFIG. Use a bounded queue between poll and process to prevent unbounded memory growth. Flink has auto backpressure that throttles sources when syncs are slow. Windowing groups records by time. Processing time uses the wall clock when the record is processed. Event time uses a timestamp embedded in the record. Event time is harder but necessary for out-of-order data. Use watermark strategy with bounded out-of-orderness. Set allowed lateness to include late events within a grace period. Use side output late data for extremely late events. This is the same issue we highlighted at the start. Here's exactly why that happened. The state store was configured to heap mode instead of disk. With 24-hour windows on a high cardinality key, userid, the state store grew to 50 GB and crashed the JVM. The fix: switch to disk mode and cap memory. The fix was to change the state store config to disk mode, set RocksDB, block, cache size to 256 MB, and add a state TTL of 1 hour. Also enabled logging to offload changelogs to Kafka. This prevented unbounded memory growth and resolved the OOM crashes. The incident was caused by using heap mode for the state store. Always use disk mode with RocksDB and configure memory limits. Defaults will kill you. Default RocksDB config in Kafka Streams uses in-memory block cache that can grow unbounded. Always set a custom RocksDB config setter to cap memory. Otherwise, you'll hit OOM under load. Never use unbounded queues between poll and process. Under load, the queue grows until OOM. Always use bounded queues with a sensible capacity. Never use select for update in a batch loop for stream-like behavior. I've seen this cause a full table lock on a 500 GB table, taking down the entire service. Use Kafka or a queue instead. The article shows exactly once v2, which is available in Kafka streams since version 2.5.0. In older versions, use exactly once, without v2. v2 improves performance by reducing the number of transactions, but requires broker version 2.5 plus and transaction state log replication factor, set appropriately. The article mentions using a dead letter queue for bad records, but doesn't show code. Here's a Kafka streams pattern that sends unprocessable records to a DLQ topic while continuing processing. When scaling down or repartitioning a Kafka streams app, state stores for migrated partitions are not automatically cleaned up on the old instance. This can lead to disk space leaks. Always implement a cleanup mechanism, such as using streams config, application server config, to track assignments and delete stale state directories on rebalance. Use Kafka consumer groups to check lag. Monitor state store size via JMX or do. For Flink, check checkpoint status via the REST API. These commands help diagnose common issues. Let's run through some common interview questions. How does Kafka streams achieve exactly once? Idempotent producers, transactions, offset commits in same transaction. When choose Flink over Kafka streams, complex event time windows, large state 10 GB, multi-source joins. What is event time versus processing time? Event time uses record timestamp. Processing time uses wall clock. And a few frequently asked questions. What is stream processing used for? Real-time analytics, fraud detection, monitoring, event-driven apps. How does stream processing differ from batch? Stream processes continuously with sub-second latency. Batch processes chunks with latency equal to window. How to handle backpressure? Use bounded queues, limit batch size, increase partitions, and parallelism. Stream processing is for low-latency, real-time decisions. If you can tolerate 1-minute latency, batch is simpler. State management is the hardest part. Always estimate state size and configure RocksDB with memory limits. Exactly once semantics add latency and reduce throughput. Event time with watermarks is the standard for production systems. Ready to go deeper? Up next, inverted index and text search, then backpressure, then transactional outbox pattern. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.